Chapter 9, Formula and Variations. A formula is a mathematical statement, usually written as an equation. It gives the exact relationship between given quantities, so that when one or more values of the quantities are known, the value of the unknown quantity can be found. The quantities represented in the relationship are called variables. For example, the formula for finding the volume of a cylinder is V is equal to pi r squared h. In a formula, the variable to the left of the equal sign, which is written in terms of the other variables to the right, is called the subject of the formula. Any of the variables can be made the subject of the formula. Consider P is equal to 2 times A plus B. We can make B the subject of the formula. First, we divide both sides by 2. And so we shall have P over 2 is equal to A plus B. And then we subtract A from both sides, and we shall have P over 2 minus A is equal to B. And this is the same as B is equal to P over 2 minus A. X is equal to B plus AY squared, the square root of whole. We can make Y the subject of the formula. First, square both sides of the equal sign. And we shall have X squared is equal to B plus AY squared. And then we subtract B from both sides. We have X squared minus B is equal to AY squared. Then we divide both sides by A to remain with Y squared. And we shall have X squared minus B over A is equal to Y squared. Finally, find the square root of both sides, and we shall have Y is equal to X squared minus B over A square root of whole. Let's see the last one. Make R the subject of the formula. A is equal to 3R squared plus 2HR. Now I'm looking at this formula and trying to relate it with the general quadratic equation x squared plus bx plus c is equal to 0. If I rewrite this formula as 3r squared plus 2hr minus a is equal to 0, that looks like the quadratic formula. In this case, x is replaced by r. Now to solve the quadratic equation, we use the quadratic formula. X is equal to minus b plus or minus square root of b squared minus 4ac, everything over 2a. So in our formula, a will be 3, b is equal to 2h, and c will be minus a. Substituting those elements, r is equal to minus 2h plus or minus square root of 2h squared minus 4 times 3 times minus a, everything over 2 times 3. Therefore, r is equal to minus 2h plus or minus square root of 2h squared is equal to 4h squared. 4 times 3 times minus a is equal to minus 12a. Therefore, minus 12a is plus 12a, everything over 6. Be smart when working these questions. Tricks mostly lie in applying logarithms and the quadratic formula. Good luck. Variations. Variation describes the behavior of one variable in response to the behavior of another. When one increases, Does the other increase or decrease? The way variables are written in a formula explains their relationship and hence the variation. But in every formula, there must be an element or a variable that does not change. This is called a constant or the constant of proportionality. For example, in the formula for finding the volume of a cylinder, V is equal to pi r squared h. When radius increases, volume will increase. Again, when h increases, volume will increase. But pi never changes, it remains the same. And so V, r and h are variables. Pi is the constant. Direct variation. Now, a class of students is contributing money for a project. Each student is to contribute 50 shillings. If 5 students pay, we have a total of 250. If 10 students pay, we shall have 500. 15 students, we will have 750. 20 students, we will have 1,000. 25, we shall have 1,250. 30 students, we shall have 1,500, and so on and so on. In this case, as the number of students increases, the amount increases as well. Two variables are said to have a direct proportion if an increase in one results into a proportional increase in the other, and vice versa. If the number of students is represented by n and the total amount by t, then t is proportional to n. In this case, n and t are changing, but something is not changing. Contributions per student, that remains 50 shillings. And so 50 is our constant of proportionality. T is equal to Kn, where K is the constant and is equal to 50. And so we shall have T is equal to 50N. This is our formula for this case, and it shows the relationship between N and T. In any question on proportionality, the first thing is to find K. In this case, K would be found by dividing any value of T with the corresponding value of N. An example, quantity F is directly proportional to G. F is equal to 3 when G is 12. Find the relationship between F and G and find G when F is equal to 9. In our solution, we get the relationship once we get the value of the constant. F is proportional to G, and that means F is equal to Kg. F is equal to 3 when G is equal to 12, and so 3 is equal to K times 12. We divide both sides by 12, and K is equal to 1 over 4. And so the relationship is F is equal to 1 over 4G, or F is equal to G over 4. So if F was 9, what will be G? 9 is equal to G over 4, and therefore G is equal to 36 if you did the cross multiplication. When two quantities are directly proportional, a graph of one against the other produces a straight line through the origin. So in our case, if we plotted the total amount T against the number of students N, the graph will appear as on your screen. The gradient of such a graph is the constant. If we pick any 2 points, let's say A and B, and find the gradient, that will be 1500 minus 1000 over 30 minus 20. That gives us 500 over 10, which is equal to 50. Next, inverse variation. Now, a teacher gave 1,500 shillings to students to share amongst themselves. let's see how much each student will get. If we had 5 students, each student will get 300. If we had 10 students, each will get 150. If the students were 15, each will get a share of 100. 20 students and each will get 75 shillings. 25 students, each will get 60. And 30 students, each will get 50, and so on and so on. In this case, we have 2 variables, the number of students n and the share per person s. As n increases, s decreases. Such variables are said to be inversely proportional. As one increases, the other decreases proportionately. We represent them as s is proportional to the inverse of n, or s is proportional to 1 over n. In this case too, something is not changing. The total amount to be shared, that remains 1,500, and this is the constant k. And so s is equal to k times 1 over n, or s is equal to k over n. And k is 1500, and so the relationship is s is equal to 1500 over n. Again, the idea is always to find k. For example, p varies inversely as the square root of r, and r is equal to 4 when p is equal to 3. Find r when p is equal to 8. First, we find the relationship. What is k? P is proportional to 1 over root r, and therefore p is equal to k over the square root of r. 3 is equal to k over the square root of 4. 3 is equal to k over square root of 4 is 2. And if we do cross multiplication, k is equal to 6. Now we find the value of r when p is 8. So p is equal to, now we know k is 6 over square root of r. Cross multiplication, we shall have 8 times square root of r is equal to 6. We divide both sides by 8, and we shall get the square root of r is equal to 3 over 4. To get r, we square both sides, and r is equal to 9 over 16. When 2 inversely proportional quantities are plotted, the graph appears as is on your screen. The curve approaches both axes but does not touch them. It is said to be asymptotic. This graph does not have a constant gradient. We can obtain a linear graph by plotting s against the inverse of n, that is 1 over n. And so we obtain another row of 1 over n, and now we can plot the graph. The gradient of this graph will give us the constant. If we choose any 2 points, A and B, and find the gradient, we shall have 150 minus 75 over 0.1 minus 0.05. That is 75 over 0.05, and that gives us 1,500. Next, joint variation. Variables have a joint variation when one variable varies as a product of 2 or more variables. The formula for finding the volume of a cylinder, V is equal to pi r squared h, is an example of a joint variation. Volume V varies directly as the square of the radius and as the height of the cylinder. Pi is the constant of proportionality. For example, P varies directly as the square of Q and inversely as the square root of R. P is equal to 3 when Q is 2 and R 16. Find P when Q is 5 and R is 4. And so P is proportional to Q squared, which means P is equal to K times Q squared. Also, the same p is proportional to 1 over square root of r, and therefore p is equal to k over square root of r. K is common, and so we can combine these. P is equal to kq squared over root r. 3 is equal to k times 2 squared over the square root of 16. 3 is equal to 4k over 4, and k is equal to 3. And so using k now, p is equal to 3 times 5 squared over the square root of 4. That gives us 3 times 25 over 2, which gives us 37.5. Finally, partial variation. Now, a water company charges 200 shillings standing fee per month and 5 shillings per litre of water consumed. Suppose a family consumed 1500 litres in a given month. How much bill will they pay? Bill will be equal to 1500 times 5 and then plus 200, and that will give us 7,700. What if they consumed 1,000 litres? Bill will be equal to 1,000 times 5 plus 200. That gives us 5,200. In both cases, two things don't change: the standing fee, 200 shillings, and the charges per litre, 5 shillings. We say that the bill is partly constant and partly varies as the consumption. If bill is represented by B, consumption by P, and standing fee by S, then B is proportional to P plus S, and so B is equal to KP plus S. In this case, B is equal to 5P plus 200. An example: a quantity Q is partly constant and partly varies as R. If Q is equal to 20 when R is equal to 24, and Q is equal to 80 when R is equal to 36, find the relationship between Q and R. From the information, Q is proportional to R plus C, and therefore Q is equal to KR plus C. We find R and C. We know 20 is equal to 24K plus C. Also, 80 is equal to 36K plus C. Now we have two simultaneous equations. We solve them. We can eliminate C by subtracting. If we do that, C minus C is 0, 24K minus 36K is minus 12K. 20 minus 80 is minus 60, and therefore K is equal to 5. So what is C? We substitute 5 in any of the equations. 20 is equal to 24 times 5 plus C. 20 is equal to 120 plus C, and C is minus 100. And so the relationship is Q is equal to 5R minus 100. Final example: a quantity Y varies partly as x squared and partly as x. When y is equal to 6, x is equal to 1, and when y is equal to 30, x is equal to 3. Find an equation relating y to x. In this case, y varies as x squared and also as x, and so we shall need two constants. We choose A, the constant for x squared, and B, the constant for x. And so we shall have y is equal to ax squared plus bx. That's our general equation. We are told y is equal to 6 when x is 1. Therefore, we shall have, substituting that into our general equation, 6 is equal to a times 1 squared plus b times 1. That gives us 6 is equal to a plus b. Let's call that equation 1. Also, y is equal to 30 when x is 3. So 30 is equal to a times 3 squared plus b times 3. That gives us 30 is equal to 9a plus 3b. We can simplify that by dividing everything by 3. We shall get 10 is equal to 3a plus b. We call that equation 2. Equation 1 and 2 can be solved simultaneously to find a and b. We use substitution method. Rearrange equation 1. A is equal to 6 minus b. Substitute this into the second equation. 10 is equal to 3 into 6 minus b plus b. 10 is equal to 18 minus 3b plus b. Minus 8 is equal to minus 2b, and b is equal to 4, which means a will be equal to 2. That is 6 minus 4. And so the relationship will be, substituting that into our general equation, y is equal to 2x squared plus 4x.
And so the biggest challenge is not falling behind, and the strategy is do whatever needs to be done so you don't fall behind. Seek help wherever you can find it, from students, from student help centers, from the teacher, from the teaching assistant, wherever you can get it. Because if you fall behind, it's like you're missing a floor in the building, you're missing a brick in the wall, and you just can't build the second floor without a good understanding of the first floor. It applies course to course, it applies class to class. Miss a class, one class, maybe that's fine. Miss 2 or 3 for whatever reason, the rest of they're speaking a foreign language for you, and you just have to make it up, or going to class has no point. If you don't go to class, it just gets worse. It snowballs, and once it starts going downhill, you're in trouble. And so the biggest secret, or the biggest piece of advice, is get help early from as many people, and there's lots of sources for help, that other students in the course, teachers, etc. And so go there for it, and go early, and go as often as necessary.